Okay.
Well, welcome to the May 25th, 2021 session of TangerineSDR and HamSci technical session. My name is Dave, KV0S, and this week I've been taking old radio projects and that didn't work and getting them working. So I've had a bit of satisfaction in those. I also spent most of the week last week teaching. I think it'll be my last class, but it was a short course, 8 hours a day, 5 days. And that kind of takes it out of you for other projects. So anyway, I'm back. And so that's my week. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. We just finished up at the University of Scranton. I turned in my last set of grades today, and I'm starting to move into the summer mode. So I'm trying to organize I've got a number of different students working with me on projects this summer, about somewhere between 6 to 8. We'll see what the final number is, but it's really good. And I also put together a presentation for the Super Darn workshop, which is technically virtual this week. So I have a new presentation, or an updated presentation, on traveling atmospheric disturbances in the RBN PSK reporter and WhisperNet data. And my goal is to try to get to the magnetometer to Majid this week. It's just been a lot with the end of the semester, but I think we're getting through that. So we're moving along. W2NF, back to Nat.
Well, fine business. And next on the list, we have Bill in 8ET. Go ahead, Bill.
Okay, very good. Yeah, I spent this week getting ready for 4 days in May and did most of the videos for that. It went fairly well, except for a couple of times when I started a video. Every time it throw me, they put me over as host, it'd be on mute. And so I'd lose the first few seconds of audio till somebody reminded me, and I'd kick it off of mute. But that seemed to go pretty well. I've also learned that these all-day conferences are tough to run, as Nathaniel probably knows. You there one or two times about 3 or 4 in the afternoon, I just wanted to go to sleep while somebody was talking. They're all interesting talks, but get pretty long in the tooth after 5 or 6 or 7 of them. So I've recovered from that. I've been pulling a lot of weeds out in the yard, and got to set up and look around and see what's going on in the rest of the world now. So that's about it. Back to you, Dave.
Well, fine business. I know what I was helping quite a bit with the last DCC, and I assume the next one, and John, as well as John, and I know we and Scotty too. It wears you out to do that all day for a couple of days, and it's one of those things you can't go and have a cup of coffee. It's like you got to keep after it all the time.
At my age, I'm just glad the bathroom is right there.
Yeah. So next on the list is John, N8UR. Go ahead, John. Welcome.
Hey, hello, Dave and gang. Well, I normally don't attend to these calls. I should, but Scotty asked me to show up tonight, so here I am. I've spent the last week with a couple of HV spectrum analyzers and pieces all over the bench. Not one, but two at once decided to need some work. On the Tangerine side, the good progress is, and Scotty may talk about this as well, we have found a replacement TCXO, the one that we were originally planning to use. The company decided they really weren't interested in talking to us about selling us any, but we were able to get connected with Microchip, and a Vectron product. Microchip is bought up just about every time and frequency company out there, and they own Vectron. They found a quite nice part. It actually has better specs than the one we were going to use, and it's more expensive, but not absurdly more expensive. So now that we've got that in, we can at least finalize our parts content. And also, I just yesterday got in the mail my new toy that will let me do some phase noise measurements directly at 122 megs. So we'll be able to do a better job characterizing the clocks. And that's about it.
Well, fine business. And next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Thanks, Dave. Well, I have my magnetometer up and running, and got that working, got it built into the necessary PVC pipe and everything waterproofed and in the ground with the bubble level on the top, and collected data for a couple of days. Once we get into the open discussion, I'll show the data I have collected working with Dave Witten on some updates to the software that he wrote for that. I need to interface it to the Tangerine local host, so there'll be a function in the local host where you can hit a button for magnetometer calibration. It will show you what the readings are on the different axes, and the idea is that you rotate it until the Y is as close to 0 as you can get it, and then you should be able to compare your results to the International Geomagnetic Standard. And I'm still getting to the point where trying to get everything lined up to compare. I mean, this isn't a calibrated instrument, but we're going to do the best we can on it anyway. So anyway, I collected 24 hours worth of data prior to when I lined it up with Magnetic North. So, but anyway, it's interesting to see. It reminds me a lot of some earlier data that was collected along these lines, but I don't have a perfect memory of that. So folks can take a look at the data I've collected and see if it looks reasonable. So back to Ned.
Well, fine business. And next on the list is Brian, 82BA. Go ahead, Brian.
Hello, everybody. My week was busy wrapping up the semester. We had commencement on Saturday. I'm still here just kind of learning the ropes, interested in hearing what everyone's been doing. I've been doing my best to attend as many of these meetings as I can. So that's it from me. So back to Ned.
Well, fine business. And next on the list is Dev, KC3 PVE. Go ahead, Dev.
Hello, good evening, everyone. So we're all good here in Scranton, and I'm also participating in the Superdown workshop, as Nathan mentioned. I have a presentation recording already submitted to the workshop. So if any of you are attending it, I would encourage everyone to take a look at my presentation and make comments, provide feedbacks, so that I keep seeking to push the boundaries. Thank you.
Well, very good. And next on the list, we have Dan, N4XWE. Go ahead, Dan.
Well, thank you, Dave, and good evening, all. Not a lot going on this week. Did watch an interesting YouTube video by Christopher Barnard, who does the Explaining Computers YouTube channel. And this last week, it was about making RJ45 connectors and also wall connectors for LAN connections. The other thing I did was a little bit of Red Pitaya work and just trying to understand better. Upgraded the firmware and the one that I got from Scotty a few months ago, and kind of figuring out how that works. And that was a lot of fun, actually. So that's about it from here. Back to you, Dave.
Well, fine business. And yes, I agree. It's a lot of fun to work with. And I'm using one as a constant whisper receiver right now. It does 8 bands at once. And it's been running 24 hours a day for a while now without crashing. So keep my fingers crossed. Next on the list, we have Dave, KD0EAG. Go ahead, Dave.
Hello. I've been doing miscellaneous things, trying to help Bill get his magnetometer all set as he finds forgotten bugs in my code that in corners where we haven't looked for a while. Get those fixed. I've been working on newer code for that. That's probably it's cleaner, but probably not entirely relevant to this project. Otherwise, not great excitement on my end. If there was, I don't remember what it was. So it didn't make much of an impression. So back to you.
Well, fine business. And next on the list, we have Don, KI5KGX. Go ahead, Don.
Thank you, Dave. Good evening, gentlemen. You know, I'm often reminded that I'm in a position of relearning what I've either forgot or duplicating what other people have previously done. And last week and a half met those objectives almost perfectly. You know, I'm inspired by the group. I've been inspired by the team. And so what I've done is set up a system of antennas that can be used just for receiving purposes only, put together about half a dozen SDR type receivers, kind of a wide variety. And then finally, you know, a lot of our lives is about communicating and visualizing data. And I went back to one of my old programs that I've used for a number of years in the energy sector. It was actually first developed of all places through the JPL, Jet Propulsion Laboratory, for visualizing data and information. And through a little bit of remembering and hard work, I've been able to make that interface between the acquisition in the frequency time domain and visualizing that and setting up a database and a data structure so I can actually make scientific investigations, hopefully, and I use the word hopefully, that have some value. Now, part of this whole process is going back to the work that you, this team, and others have done in investigations to make sure that I'm on the right track, and hence that word sort of reinventing what others have done. But I think that looking at data is an important part of our work, and certainly you've inspired me to go back and relearn and redo some things in those hopes. So I've been busy. Next week is going to be an off week. I've been ordered by my chief executive officer that we're traveling up to Denver, Colorado to see our son and daughter-in-law that we haven't seen in the last year. So that's a must. So I'll turn it back to you, David. Thank you for your time. Thank you.
Fine business, and have a nice, safe trip. Next on the list, we have Hillman. I can't remember Hillman's call. K2MCR, right?
Yeah, KD2MCR, sorry.
Oh, D. Okay. Go ahead and your comments.
Yep. Good evening, everyone. Yeah, not so much going on other than communicating with Bill, Jules, and Dave for sensor installation and orientation and data quality. That motivates me to work on documentation, which I'm working on right now. So, yep, hopefully I can prepare for more consolidated documentation as soon as possible. But other than that, yep, there's not much going on. Back to Ned.
Well, fine business. And next on the list, James, KG4DSG. Go ahead, James.
Good evening, all. Just listening in as usual, and looking for time to play with my new toy. Just got it this weekend. The Picos are out now in stock. If you don't know anything about them, they're a Raspberry Pi that costs $4. It's a dual core ARM processor. I'm looking forward to some interesting projects, and we'll see where it leads. With that, back to the net.
Well, fine business. And next on the list is Jay, WB8SBI. Go ahead, Jay.
Good evening, everybody. First of all, Nathaniel, congratulations on getting the CQ magazine nomination. That's really cool. That's cool, guy. It's well deserved. And hopefully, and I have no doubt you'll get a lot more in the years to come. Not only ham radio related, but National Science Foundation, things like that. So, and I hope you and your family are all safe and well. Other than that, I received from Amazon my starter kit on how to learn how to solder surface mount components. I still got to order the soldering iron and the magnifying station, but I'm making progress in learning how to solder surface mount components. So it's happening slowly but surely, but it will happen. Other than that, not a whole heck of a lot to report ham radio wise. 73 to all. And also get ready for field day, people. It's coming up. So take care. Back to Connect Control from WB at SBI.
Well, Jay, Nathaniel's got the right shirt on. So next on the list, we have Jim, K4BSE. Go ahead, Jim.
Good evening. Well, let's see. I on a local net just a little while ago, I learned of the coronal mass ejection that is supposed to hit the Earth tomorrow night, and I'm looking forward to seeing what that does to the WWV signal that I'm watching with my Grape 1 receiver. I will have about a week and a half of good data prior to that to compare with. So looking forward to that. Otherwise, not a whole lot happening on this project. I need to figure out what I need to do now. Back to net, K4BSE.
Fine business. And next on the list, we have Joe, K7LUX. Go ahead, Joe.
Okay, thank you, Dave. Been busy assembling a second Grape receiver. Got it running, and the traces I'm getting are quite a bit subdued compared to what I was getting a month ago. So I think the ionosphere is being a little less turbulent than it was. Anyway, as far as assembling things, I bought some 0.015 inch diameter solder from DigiKey, and boy, does that make life easy. That and a real sharp soldering iron. I'm not kidding. I used 0.25, and that went on in globs. So the 0.15 works very, very much better than the larger stuff. Plus, it's newer, which probably contributes to the overall success. The other thing was I finally attended my first Thursday morning Grape video conference, and enjoyed the discussion on how one goes about measuring the time of flight of these shortwave signals. Back to you, Dave.
Well, fine business. And let's see, next on the list, we got John. So it's Jonathan Rizzo, KC3EEY. Go ahead, Jonathan. Jonathan, are you there?
Hi, everybody. This week I was looking at ways to prototype the or ways to connect the duck board of the ADD converter eval module to the Raspberry Pi and BeagleBone Black. There's a driver for the BeagleBone Black that's available from TI. I found that Easy EDA has the footprints all ready made for the connector that I need, and different sorts of capes and hats. So I could probably just do a quick two-layer board just to get it connected and attached to the Raspberry Pi buses. Since John is here, I wanted to ask him a question about the pulse per second signal during holdover. I don't know if John, if you thought about that, or if that was something that the FPGA was going to handle, or if you discussed any of that with Scotty. Other than that, my graduation ceremony was yesterday. It was an absolutely surreal experience. Crazy to be done after 9 years of going to school. And incidentally enough, I got a mailer from Wilkes telling me to register for master's classes for the fall, which was pretty funny. Other than that, I don't have anything else. Back to the net.
Fine business. And next on the list, we have Con, KE8QWB. Go ahead, Con.
Hey, y'all. It's been a while. I've been traveling a bit right now. I'm right outside of Glacier National Park. I can't really do much for radio because it's raining. It's going to rain for the next couple of days too. But in the meantime, I'm just programming and reading up on the ARRL handbook. That's pretty much it. Back to net.
Well, fine business, and we'll look forward to you getting back. Next on the list is John, KJ6IBP. Go ahead, John.
Not much to comment on. My Pi came in. This is like the most expensive thing that's that size I think I've ever bought. But that's like my first step in this effort. So I just have to get it configured. Assembling it was really easy. Configuring it, that should be interesting. And installing relevant programs into the thing. When this hardware is developed, then I'll attach it somehow. And not much other traffic.
Well, that's fine. Thanks a lot, and enjoy learning about the Pi. Okay, next on the list, we have Michael, AA8K. Go ahead, Michael.
Oh, thank you, Dave. Greetings to everyone listening. Had a minor success today. I got Lynn HBSDR talking to Pulse Audio. So I got it capturing RWM right now from Moscow onto Audacity. So we're going to make it for the Eclipse next month. I just sat down and started going through all the permutations of the settings and found one that worked. Wrote that up. Back to you, Dave.
Well, I'm glad you got it working. So hopefully a little advice helped. And so next on the list, we have Scotty, WA2DFI. Go ahead, Scotty.
Okay, just a second here. I want to turn off my virtual background so you can see the junk in my office. Oh, I guess I got to turn the video.
You got to turn on your, there you go.
Okay. Anyway, this is for John's benefit, John Ackerman. This is the evaluation board that is built now. I don't know if you can see it. Okay.
Yeah, it looks good.
So when we get to the free-for-all, maybe you can explain what this is supposed to do. It'll be better than I could explain it, but it's a tool that we're going to use to validify the clock module assumptions that we've made, right, John? Is that?
Yep.
Okay. So anyway, we had it built by the CM here because we were all pretty busy and we wanted to have it done professionally to get it done quickly. So this week we actually just ordered the oscillators for the clock module, the replacement oscillators. So then they claim that they're in stock. Now I'm not sure why it takes 2 weeks to deliver them because I mean This is the age of Amazon, right? If they're in stock, they should be in my mailbox like tonight, right? by 10 o'clock.
Hey, Scotty, you made a comment about this, that somebody orders something from you and you have to mail it the next day, or people get
They get
angry.
upset. They want, it's like, no, it's like the same day. It's like they want the tracking number along with their Visa card confirmation.
Yes.
So at any rate, they're claiming 2-week delivery, which is fine. But the good news is that it's in stock, that we can get them. The price is reasonable. And by the way, well, you saw the price they gave us, John. They gave us a 100-piece price for our prototypes. So it's a nice touch for them.
Good.
They didn't have to do that. And I've been progressing along on still going on the data engine, doing the last set of swaps. We got the Ethernet part swapped out, and the new 7-port Ethernet chip swapped in, the one that I could actually buy, and that we actually have in hand. Now we have those parts. So it's down to, believe it or not, the FPGA and the USB 3 chip. Those are the only 2 chips that I don't have in my hot little hands or in my large boxes in the other room waiting to be put on boards. So the Ethernet chip is scheduled delivery is middle of August, but they've been able to beat their prior commitments. So I'm hoping I'm going to get it a little earlier. The FPGA, I still don't know yet. They supposedly have logged the order this week, but it's just one hurdle after another. We were below the minimum order quantity, so we had to get a waiver so they would accept our order. So Arrow would accept our order. We got that last week. And now once the order gets put in, then my local rep guy can go beat on people and see if he can scrape up some parts for us. So we'll get a delivery date probably by next week. I'll know whether I'm going to be in trouble or whether we're going to be able to go, because there's really, if I don't get the FPGA, there's nothing I could do. There's no other alternatives, and I can't not put it on there like I can with the USB 3 chip. So, and so the next plan, I guess, is to take this board here when we get the oscillators and take a couple of them, replace the oscillator, replace the Raycon unobtainium oscillator that's on this board with the Vectron one that we're going to actually use. So we bought some spares so that I can ship them off to John, and he can do his magic with his brand new toy there. And actually, you don't need your new toy for this, do you? But,
yeah, because we'll be looking at the 12288.
Okay, because that's right. You're going to hook this up to the synthesizer program for 12288 and do direct measurements. So we'll get a much better idea of exactly what the performance is going to be of the clock module. And we still have to go back and make a few tweaks to the clock module and the RF board. And as soon as we get this data engine tied up, I did finally get all of the IO input into Quartus. This 500 IOs. I got all the pin assignments in, so that now I'm going down through the list of errors that I get that say, "Oh, that won't work. You can't use that pin." But it's actually only 2 errors, so it's not really that big. But it was a big deal entering 500 pins into a table in the tool. There's no other. I guess there's a way I could do. I could type it all in and then have them imported. But typing's typing is. It's one thing or the other. So anyway, that's all in. So I'm envisioning a few minor tweaks to that as our CAD guy makes his final round of pin swaps for the Ethernet connections that he had to, the chip that he had to swap out. And the only other thing is that, and maybe you want to talk about this in the session, we built a different board for another customer, and I used the same switching power supply on the front end of our data engine as I used on that board. And we're seeing a lot of noise on that board, switching power supply noise. It's making me very nervous because we use the same design. It came out of, it's a TI part. It came right out of the TI app notes. So I mean, the data sheet. So it's the standard thing. So what I'm thinking of doing is making provision for adding a shield over this power supply, maybe increasing some values of capacitors, because I think it's mostly conducted noise. So I think we need maybe some more bypasses, some more high frequency bypasses. So we may make a few of those changes before we actually tie it all up, because I don't, the lower voltage supplies are all the Amperian parts with shielded inductors, internal inductors. So I'm not really too worried about those. They're really low noise parts. They even claim that they're for RF type applications, but this TI part is not. So, because we convert 12 down to 5, and then we basically use a 5-volt bus, and we regulate all of our lower voltages off of that. So if you get a lot of noise on the 5-volt supply, it's not going to be good. So we want to try and sidestep that, because I mean, we try to do the best we can. We've separated things. We've put lots of ground stitching in, twisted or matched pairs where we need them, controlled impedance where we need them. But you can never be too sure that you're not going to step in something and have a problem. So I'm going to try and mitigate it as much as you can in advance. So anyway, that's about it for this week. Back to you, Dave.
Well, fine business, Scotty. And next on the list is Tom, N5EG. Go ahead, Tom.
Oh, good evening, Dave, and everybody in the group. Tied up this week with other activities. I did get 2 new receiver characterization tests working in GNU radio. One measures wideband spurious lines in the A to D converter. That was interesting in using vectors in GNU radio. It has interesting things like you can build a low pass filter, and by defining a certain vector size, what you have is 16,000 low pass filters in parallel with one block, and it executes pretty quickly. Also, you figured out how to use vectors to strip off the mirror image spectrum from real FFTs. Also found a fairly significant amount of DC offset in the Hermes receiver, about 2 millivolts or about 64 ADC counts, and have a setup in GNU radio that will find that now. So I'm just slowly adding characterization tests to the receiver. Back to the group.
Tom, can I ask you a quick question? Have you gotten any feedback on your recent post of a new driver for GNU Radio 3.9?
I haven't gotten any feedback, but my GitHub site got about 60 or 70 hits when I got it, when it came out and the release was tagged and put out. So I think there's a few folks who probably noticed it.
Well,
it hasn't been widely announced.
I am one of those.
Okay.
But I was just curious if anybody tried it much or how far it's gone.
No, I don't know. It's upstream from a couple of other forks. And so if those folks go to 3.9, I expect they'll do a poll to get the upstream.
Yep. Very good. Well, that brings us to the end of the list. And unless I missed somebody, we're open for general discussion.
Scotty, noise on power supplies. Normally conducted noise is due to 1 or 2 causes, one of which is the need for very low ESR or very low equivalent series resistance filter capacitors. And if you get poor quality filter capacitors in the design, they'll have hundreds of milliohms of equivalent series resistance, which will increase the output noise. And the second is the grounding of those bypass capacitors and how they circuit-wise tie into the part. It's very easy to get ground loops and things that couple input to output noise. So those are generally the 2. If you have a pre-built module, I'd look at getting very low ESR bypass capacitors for the output.
Okay, because on the TI part, it's not a module, so we have an external inductor, but the MOSFET and the diode are built. The fly diode are built in, flyback diode, and we use only like X7R, high quality bypass caps, and I don't even like Wi-Fi Vs. I like the more robust dielectric, which are a little more expensive, especially in the higher values. But I guess the question is it, in the old days, we used to use a 1 microfarad, a 0.1 microfarad, a 0.01 microfarad. We put decades of capacitors in parallel.
because the smaller capacitors have less inductance at higher frequencies, so they're actually more effective at the higher frequencies. Is that still true with modern caps?
Yeah, probably still true depending on lead length. Typically with power supplies, if they're switching in the 40 to 300 kilohertz range, it's not so much the inductance, it's the equivalent series resistance of the capacitor that limits the filter performance. And so if you need a large bypass cap, you may need a special cap that's got good ESR performance. That's normally what we found in the lab, were the quality of those caps.
Well, but what do you mean by a special cap? Because
high quality power supply bypass capacitors that are engineered to have low ESR. Generally, if you do a search on bypass capacitors in the right microfarad range for your supply, you'll find some that have a low ESR spec when you search.
Okay, so specifically made for power supplies then?
Well, yeah, or for any application that need a low equivalent series resistance, but usually that's power supplies.
Okay, yeah, okay. Because I've just been picking general purpose type capacitors, but I pick good dielectric. I don't, because you could pick some, especially with larger caps, it's easy to pick kind of sloppy dielectric that doesn't have very good ESR.
Yeah, the RF capacitors, the dielectric will determine the loss tangent of the capacitor. But when you get down to the lower, hundreds of kilohertz on down kind of frequency ranges, the capacitors get big. They're in the 10, 20, 50 microfarad range. And then there's a different set of optimizations needed to make those capacitors more effective.
So it's more of a question of the larger capacitors, like the 10 microfarad and up, rather than the 0.1s and those kind of guys.
Exactly. And so working those couple of big bypass capacitors and getting the right kind of caps generally is a real big help.
Okay, and what about is shielding useful for anything?
It can be. Normally shielding helps with reduced radiated noise rather than conducted noise. The other thing for conducted noise is to minimize the area of the loop formed by the inductor, the chip, the MOSFET, the diode. You tend to want not to have that be a big loop. If that becomes a loop, then what you have is a one-turn transformer with the flux coming out the board through the core, through the center of the loop. So if you minimize that loop area, you minimize the ability of that to radiate.
But that's magnetic, right? As opposed to
it's all electromagnetics.
So okay, so I'm thinking in terms of a steel shield versus an aluminum shield. See, or a metal shield.
Yeah. So if you have problems with magnetic leakage, of course, aluminum doesn't work because its magnetic permeability is 1. So it's it's equivalent to air in terms of its magnetic field filtering. But I'm not sure it takes a real special application to need a mu metal shield, magnetic shield. That's not a common need. There's a few cases, but it's not common. But you'll find that if you can minimize that inductor loop area in your trace layout, that you'll help reduce some of those conducted artifacts as well.
Yeah. So can I share my screen here, Nathaniel, for just a second?
Yeah, it should be. You should be able to go ahead and do that.
Okay. Okay, did you see the layout of the board here?
Yes.
Okay, so up here, and can you see my cursor? Does it come across?
Yes, it does.
Okay, well, up here in the upper left, this is the power supply connector, the input power.
Okay.
This is the 12-volt regulator.
Okay.
It's clustered right in this area right here.
Yeah.
And you can see how he puts things as close as he can together.
Okay.
This is layer 1. So, and underneath it, we have a solid ground plane.
Okay.
So
mostly.
I mean, there's in that area anyway. There's a few clearance holes for capacitors here, but that's this area right here, and that's probably that plane on the top, that little mini plane, is probably this right here is the a balun, okay, a filter.
Okay.
On the input.
Yeah.
It flows to here and here. So this will be the ground side. This will be the power side. So the power goes into the regulator, and this goes to ground, which is again the plane completely underneath.
Yeah.
And then on the output side, this is, I'm going to guess this is the inductor. Let's see if I can. Yeah, so I can see if I can make this a bit bigger. No, maybe not that big.
Okay.
So there's the inductor over here, and these are the bypass caps here.
Okay. Can we see how the traces are?
Yeah. Let's see. You go here. Unfortunately, I can't put assembly and layer 1 on at the same time with this PDF, but
yeah. So the layout guy's done a really great job getting L1 close to that part in terms of minimizing area there. I think he's done a really good job.
Yeah. And then if you go back to, okay, so that's the 12-volt supply that regulates down to 5 volts.
Yeah.
And then let's see, one of these planes is a 5-volt plane, and they don't come across in this PDF because he has to do a flood. So like this little green here, that's an empty gap, and this is flooded, and this is flooded. So I don't know which is the 5-volt plane. I think this is the 5-volt plane right in here. Okay. But I'll go down to the primary side, and if you look down here, and you can kind of, these jump out at you because there's 4 power supplies that are virtually identical.
Okay.
Here 1, 2, 3, and 4. So this IC right here, this is the module.
Got it.
Okay, with a pad under it, and the inductor is actually over here, and everything else is in the electronics is over here, and it's all inside the module. And these are really nice because they're really low radiation. They use a flat type of coil.
Yeah.
And they're shielded.
Right.
So what he's done is laid one out, and then he lays the other ones out just identically to them. And this is like the 3-volt power supply, the VCCIO 27, the VCCIO 34, and this is like the 1.2 volt supply. And then there's a couple of sorted LDOs that are in other places, but these are the 4 switchers.
Okay. Well, he's done a really good job keeping them compact.
Yeah, he kind of keep them away from everything else, which helps, I think.
Yeah, so his layout, I think, is really good. So if that's the case, I would focus on making sure you have a big enough output bypass cap of the sufficiently good ESR. That's generally your best bet.
And I'm thinking that this is probably the caps right here, the across here, and some smaller ones here.
Yeah, do you know what kind of caps they are?
Yeah.
Well, we could talk about that later.
Yeah.
You know, a problem I have seen before when you parallel caps like that, different values, and this goes back to my experience with leaded components. I'm not sure about surface mount components, whether they going to react the same way or not, but I've actually run into a case where putting the caps of different values next to each other caused a problem, because somewhere the higher value cap had gone inductive on me, and it was forming a parallel resonance with the lower capacitance cap. So I was actually getting a parallel resonant capacitance, a parallel resonant circuit where I thought I had good bypassing to ground. Just at some frequency range, it was just the opposite of what I thought.
Yeah, you kind of always run that risk. I mean,
yeah.
Unless you could simulate the board, but that's pretty much beyond the scope of the software I have. But one of the things that he does is, you notice that there's 3 vias.
Yeah.
Each pad here.
Mm-hmm.
So he's trying to get a nice low impedance path to either the ground plane or the power plane that's on one of the lower layers. And so it's, and of course these connect to the plane here, but he's got like 6 vias here on each side. 8 vias there. And so, and I actually read an article sometime back about grounding of capacitors, bypass capacitors, and they're actually saying that they did comparisons with a via to the side of the capacitor, a via to the end of the capacitor, and it turns out the most optimum grounding you can get is to put a via on either side of the pad.
Okay.
Now they were talking about like 0402 and 0603s. These are larger ones because these are probably 22 microfarad or 47 microfarad or something bigger.
Yeah, you have issues when pads are all on one side, the magnetic fields add, and when the pads are on opposite sides, they tend to cancel each other out.
Okay. So it might be illustrative for him to add some pads over here, some grounds over here. If the ground plane, well, he does have a ground plane under there, but then you have the opposite effect. If you put too many holes in the ground plane, then it reduces its effectiveness.
Yeah.
So there's some trade-offs to be had. But in general, I kind of like this because everything is close to the part.
I mean, he's obviously a good layout guy, because I think that looks pretty nice.
Yeah.
Have you actually had problems with this particular supply?
Not with these.
Okay.
It was with the other one up here in the corner that we used the same supply on a different board, and we're actually evaluating that board right now. So the jury's still out as to what's causing the noise.
Okay.
Oddly enough, we had a lot of noise generated by the fans in the DC fans. And so we had to rearrange some wiring to isolate the fans from the logic from the because we have it's basically an SDR board. We've got a couple ADCs on it, and we're getting like a bunch of noise coming in the input of the ADCs to the point where we're losing a bunch of effective bits because of the noise. And it looks like it's coming from the power supply. So and the problem is, while the layout is different of the supply, the circuit is basically the same. Because
is that circuit actually powering the fans themselves?
It's power, yes it is.
Okay, so that fans having very high inductance and high current loads put in even more of a premium on the quality of the output capacitors.
Okay. Well, what we've done in the on that board anyway is we've removed the fans and put a separate regulator. It runs on 48 volts, so we have a complete separate regulator to run the fans and the other logic other than our board.
Okay.
So,
well, why don't you let's have a couple of emails during the week and exchange some part numbers that might be usable or useful.
Okay, yeah, because we've already ordered all these parts, but I just ordered generic caps, so it would be good to go through and pick the right ones for what we want to do.
Okay, why don't you send me the list of just the caps in that power supply? I'll look at them and see if they're good choices or if there's better choices available.
Will do, thanks. That'll help.
Okay.
Okay, and then I think Jonathan has some questions for John, if I could figure out how to unshare this thing. Oh, there we go. Okay.
I have some for you, Scotty.
One other thing before you get started, Dave, is that I'm giving a talk Saturday at and I don't know if anybody knows about this, but it's called the YouTubers Ham Fest. Nobody knows, nobody's heard of it. Anyway, it's run by Jason, who runs Ham Radio 2.0. And there's a whole bunch of talks starting. It's mostly a like a social on Friday, and then there's talks on Saturday and talks on Sunday. So I'm going to be talking about the TangerineSDR at 7 a.m. Central, 7 to 7:30 Central, which is great for me because that's 5 a.m. my time. So
that is early.
I will be semi-coherent, and if you want to take advantage of me, that'd be the great time to do it because I won't be really awake then. So anyway, so you had a couple questions, Dave?
Hey, Scotty.
Yeah.
I'm sorry. Can I jump in? If we've got anything on the CKM, could we cover that now? Because my eyes are starting to flake out a little bit, and I need QRT.
So, Jonathan, you had some questions for John?
Yeah, I was wondering how the pulse per second signal was going to be handled in holdover mode.
Yeah, that is the one negative of the design that we're using, in that we're not synthesizing the pulse per second from the disciplined oscillator. Normally, we're using the PPS that's coming right out of the GPS module. The plan is that in the FPGA on the data engine, we will generate a PPS from the disciplined output clock and synchronize that PPS to the GPS PPS. So if we go into holdover, that pulse per second will continue with the same stability as the TCXO through the holdover period. So we have to do that in the FPGA, not on the clock module itself. But that's the plan. And if we need to synthesize the NMEA timestamp message, we could do that as well. But I'm sort of hoping that that it's only just getting the PPS signal that's important, and not continuing the ASCII message stream.
Okay, yeah, I was just wondering how that it was going to handle it, how it was going to be handled. Normally with the stuff that I use, if the GPS loses signal, then the GPS module, its internal oscillator takes over, and you just have to deal with the reduced performance. So in this case, we'll have some better performance, and using the FPGA to synthesize the pulse per second signal from that. That's a good idea.
The GPS, I'm sorry, the pulse per second coming out of the GPS goes insane quite quickly when it goes out of lock. And unfortunately, I don't know why they don't do this, but the U-Blocks module doesn't seem to have a way to turn off the pulse per second if it's not locked. It keeps running, but yeah, it's pretty ugly pretty quickly. So we'll figure if we can just keep that synchronized, internally generated PPS available, that should give us, you know, the equivalent of the TCXO. And the nice thing about the TCXO we're using now, this replacement, the specification for holdover is it in over 24 hours at constant temperature, plus or minus 40 parts per billion. So that ain't too bad for 24-hour of free running.
John, can't we turn off the one PPS?
We can command it to turn off, but we can't. There's nothing that I've found that will have the GPS automatically disable the PPS if it's not valid.
So we'd have to look at the NMEA sentences, determine we're out of lock, and then shut it off.
Yeah.
Is that possible within 1 second?
Yeah, well, I would think so. I mean, within a second after the out of lock message is received, yeah, that should work.
And when you say it goes crazy, what does it do? I mean,
it jitters around. I mean, it's not like it's a half second off immediately, but it doesn't degrade gracefully from being on time to drifting off. It jumps around and just not a very nice signal.
It would be in our best interest to turn it off then.
Well, to turn it off or to switch and just
switch to yeah.
Or the other option actually would be to initially synchronize to the GPS PPS and just drive the system from our synthesized pulse per second, and every now and then check its sync against the GPS signal.
Well, we can generate the one PPS in the FPGA,
right?
Use the GPS to synchronize it as long as it's locked, and then not use it to synchronize it if it's not locked.
Correct. Okay. That's a better way of saying what I was trying to.
Okay.
Oh, all right, good. Yeah, because I was, it wasn't anything that I was too worried about, because normally you just kind of considered that data not as good, but for time stamping, I would hope that there is some sort of a, well, is it possible, instead of using NMEA sentences, is it better to use the uBlocks binary format? Would that be a little quicker in determining whether the PPS signal is not usable?
I don't think so, because they're all going to be running at a 1 hertz rate typically, and we can get the lock signal. It's a bit in the binary message, and it's a byte in the NMEA. We can pick it up from either. We can command what sentences we want to have turned on, so we can use a mix and match of binary and NMEA if we need to.
And there's a lock signal, right? But that comes from the
No, there isn't. That's the problem. The GPS does not have a lock signal. The synthesizer does.
Okay.
Well, I on the Trimble units, it'll tell you the quality of the PPS in the Trimble binary format. And I was wondering if that was available in the uBlocks binary format, and it would be quicker because with the NMEA sentences, you usually have to wait a certain amount of time. In the olden days, back when everything was 9600 baud, you would get a sentence every second, but nowadays with faster baud rates, can the NMEA sentences be spit out a little faster than once per second?
Yeah, well, they might be, but they're not going to update more often. I mean, it only does a solution once per second. So it's going to take the receiver a little time to know that it's out of lock.
Okay. Okay.
And we can run the NMEA at 115K bit per second if we want. So we can run the serial fast, but the GPS is not going to be instantaneous in lock unlock.
Right. Well. I mean, the Trimble units aren't either. But they usually send out those bytes within that second. So you know that
yeah.
Once it reaches that second, that pulse per second signal is not usable. And I believe the uBlocks has a similar thing.
Yeah. The uBlocks binary can give the status and whether it's locked or not. So we can use whatever works. I'm just not sure that there's much of a time difference depending on the message format. I suspect that it's all going to happen within the same second either way. But we can certainly use the uBlocks binary just as easily as the NMEA.
Well, as long as you get it within 1 second, it doesn't really make any difference because you're not going to get another PPS until 1 second anyway.
Right, and also if we synthesize, and if we're using the synthesized PPS, it will remain valid if the GPS loses lock. We just have to have it not resync to a bad
right, because
GPS pulse.
We're counting off the megahertz for that 1 PPS, right?
Right. So we're going to have some kind of a time constant in that sync system, so it's not going to instantly lock itself to a bad pulse.
I bet we could mess that up pretty easily if we tried.
I'm sure.
Seeing as how the Hermes one works so well.
Oh, that's good. Yeah, because it's not. I mean, it's not something that I'm super worried about, but I just want to make sure that there's some sort of time stamping facility available. I mean, and if let's say that we see from from either the binary or the ASCII sentences you know, that pulse per second isn't usable, then we could kind of switch over to the FPGA, creating the pulse per second signal from the holdover oscillator, and you know, we should be fine.
I suspect that it would be better to use what I'm going to call the synthesized pulse per second that's coming from our TCXO to synchronize the synthesized PPS every so often against the GPS, and then but use the synthesized through the whole system. So if we do lose lock, there's not going to be any jitter on the PPS in the short term. It'll just continue without any kind of phase change.
I'll give you a pulse per minute output, so accurate to the nearest minute.
Pulse per fortnight, please.
Okay.
So anyway, Jonathan, I think we've got a number of different ways that we can do it. It's only code.
Yeah.
Yeah, it's only code.
Only code.
We call it it's SMOS, simply a matter of software.
Yeah.
Did you make that up, or is that a known acronym?
Oh, that's got to be 35 years old.
Yeah. There's a Tom Clark saying from back in the original TAC days, or something like it's a simple matter of programming, or something like that.
My professor at ASU, his version was load A, store A, how hard could that be? But that was assembly language, so most people don't get that nowadays. But he had the same version, along with telling all of us that he knew that we all sat home during Mission Impossible on Sunday night doing the homework that was due on Monday, that we had a week to do, but we would say at 9 p.m. we'd be doing the homework for the next day.
So, okay. Well, if we're finished up, I'm going to sign off on that. If there's any other questions, I'm happy to stay.
I know. I wish
Thanks
Dave
for showing up, John.
Yeah, I'm sorry I'm not here more often, but kind of unfortunately, I tend to shut down fairly early in the evenings when I have to get my contacts out. So starting at 9 is a little bit of a challenge for me.
Well, we appreciate you coming by. I wish Dave was here, because Dave, N1HAC, he had some questions too, but he didn't arrive tonight. So, oh well.
Yeah.
We try.
Yeah. All righty. Well, we'll talk to you all later.
Thanks, John.
Thank you, John.
Yep.
Thanks, John.
So, Dave, you had some questions?
Dave Whitten.
Yes.
Yes. Well, just on a very different front. Last week we discussed, I think briefly, I was making some 3D printed mounts for the magnetometer, and we were going to get together late this week, I thought, to discuss the specifics of some specifics of your board layout, so I could make some in preparation for the final, for a final board. And but it slipped my mind as well, so I didn't think to send you an email or anything. But I still would. It would be nice to have some, to know where the holes are is the most important thing for me. So, but I haven't had any takers on the mounts I've made anyway. No one seems to be very interested, so I haven't made any more.
Oh, they will be once we get lots of boards.
Oh, I do think it'll be orders of magnitude easier to set up this thing with this way than the other, but I don't know. It's just whatever people want. So, but it would be nice if the holes were in the right place.
Well, and you also mentioned that you need the connector in the middle of your bracket on the end.
Right, and I can do that. That's easy. I mean, centering it is easy. We'll put it on the other end, which is really kind of where it belonged anyway. And I think I leave the center layout alone. The 2 pin headers for the module itself are already in the center. I can't do anything about the 40-pin connector on the edge except leave it out and let people put it in who want it, and then add something behind the RJ45 connector so that they can leave that off and hook a header in there. And so the people who want to place it in a pipe and use your mounts would then leave the RJ45 connector and the 40-pin header off, and then they would connect directly into another header for the RJ45 to come out somehow, whatever you guys are thinking is the best way. Because you're thinking of coming out to a weatherproof RJ45, right?
Yeah, yeah, and that can be a pigtail from there down to the board, or it can be a well, it can actually with those female connections to the outside, you can just take a piece of cat 6 patch cord and cut it in half or something and solder to the through holes.
Yeah,
and that seems to my way of thinking a lot more tractable for, we say, solder orange white into this hole and solder blue white into that hole, and then some of the other things, and mechanically it would be, but I do want to make, really like to see the the board width and the position of the holes, I guess, are the things that really concern me.
Yeah.
I should show you folks the solution I came up with for what you're talking about there. I found this thing here. It's a through hole. Oh, it's kind of, let me see.
You got to turn up. Hold it in front of your face.
Yeah, it's a through hole.
Yeah, if you put it in front of your face, it won't. There you go. Now we can see it.
Yeah, it's got an RJ45 female on either side.
Yes.
And you cut a 1/2-inch hole and mount this in there, or maybe it's 3/4 of it in. Anyway, it's an available drill bit. And then there's a waterproof end that you can put on the end of an RJ45 cable. And you put that on there and screw it down, and it makes it watertight. And then on the inside, you have a jumper that just goes between this and the board. It worked like a champ.
So you just take an RJ45 jumper, right, and cut it in half.
Say that again?
Like just like Dave said, you take a jumper and cut it in half, right?
Well, I just took a jumper and a plain old RJ45 jumper and went between the one side of this and the board. Because the board that I have has an RJ45 on it.
Oh, okay.
Well, if you choose not to have one, they won't come with the RJ45 soldered in place.
Oh.
Okay.
But you can solder one on.
You've got an early one. You could do it that way, but in the case of some of the prototypes, they're at the wrong angle. And also Jules has said that some of those female RJ45s are a lot more waterproof than others. Yes. I don't know. I have many different kinds, many different brands, and his one that he likes the best was one I had to buy a whole. Well, I have lots of them. If anybody needs RJ45 female bulkhead.
But the idea would be to put the RJ45 and the header behind it in the center of the board, and then deliver the board with nothing in either of those holes.
Right.
So that if you want an RJ45, you solder that on. If you want a header, you solder that on. If you want to hook wires right into the holes, you don't have to worry about on the RJ45 the staggered holes, which one's 1 and which one's 2. You could even put an RJ45 and a header on if you wanted. The only concern I have a little is, isn't Cat5 solid wire?
Not the patch cables, as I recall.
Okay.
The patch cable, at least it used to be that Cat5, I believe patch cables were usually stranded wire, but maybe that was a long time ago. In any case, they were, they need to be more flexible than home runs. And
thinking if you soldered in solid wire directly onto the board and bent it over, then you'd have a limited number of bends before you're going to run into trouble.
Right.
Yeah.
Well, I ordered a couple of Cat 6 jumper cables to go between the shack and the magnetometer. One of them has solid wire, the other has stranded. And working with that about the 26 gauge stranded wire, that's a royal pain too.
Yes.
Yeah.
Well, there's no perfect way,
Yeah.
but we were trying to explore the options, and I think what Scotty's talking about here provides us with the most options.
Yeah.
And then I think we have an option for those who do not want to solder at all, that would have the connectors installed, and they can buy them that way if they want. But most people will buy them without the connectors installed. That's the standard way, because then it would fit in your bracket. If you put that 40-pin connector on, I don't think it's going to fit in your bracket into the pipe.
That 40-pin connector, it will not go in the pipe with that on there. And like it could in a 2-inch, but I'd have to make different brackets, and they'd take a lot longer to print, and they'd be more of a pain. They take kind of exponentially longer to print.
So if they can't solder a header, they just need to get with their buddy down the street who can.
Yeah.
And also the larger pipe becomes more problematic when you're burying it.
Yeah.
Well, let me show you. Can I share my screen? I'll show you what I ended up with here.
Go ahead.
That right here is the that's the pipe, and this is a 30-inch pipe.
And this is 1.5, right?
I believe that's what it is, because the board, I just wrapped the board with that the same bubble wrap that it was shipped in, and then it holds it very nice, and then shoved it down to the 24-inch deep mark using a yardstick. And I already had the jumper cable, the RJ45 jumper cable coming up, and the other to go to the other side of this. And then this is the hardest part was making this, because you had to take the end off of the Cat 5 or Cat 6 cable and then make a fresh one.
Slide that seal on and then put another connector on.
Yes.
Yeah. It's got a hole that the cable goes through, and then when you put this end on, it squeezes that around the cable very tightly. Now, is it going to really turn out to be waterproof? I don't know. We'll find out, I guess.
It looks like it'll be pretty good. You got a fighting chance for sure.
Yep.
And then you got your level on the top, right?
Yeah, I still have to finalize the adjustment, but this pipe, if you have a one of those post hole diggers, you can put this or 2-inch or 3-inch for that matter. I mean,
Dave used one of those drill augers, right? The small ones.
Yeah, the garden auger. It's for an electric drill, but it's for burying bulbs in your garden, I guess. And they come with 2 or 3 bits, and I got them on Amazon, but I suspect Lowe's or Home Depot might have them too.
And one of them was big enough for 1.5 pipe.
Yeah. I think there were 2 or 3 bits in the kit, and I was able to do 2 for sure. I don't know whether I did a 3 with it. If you wiggle it around, you can make it bigger. But
this is the first day worth of data before I adjusted the pointing of Y to minimize it. And so you can see like a diurnal variation, I guess, I seem to remember this from being similar to what some other people have shown. Doesn't that seem to ring a bell?
Seems very similar to what Human's been showing.
Yeah. So anyway.
Your line's fatter than the interval.
What? Say that again?
Your line is fatter than the interval.
Yeah, well, that's because, it's just you're getting a variety of different measurements because this is a whole day's worth of measurements at 1 per second. So there's 86,400 measurements in this. So there's a little bit of jitter in it.
Did you do a moving average or anything?
No, I didn't. Not in this. You could easily enough, but
Yeah.
this is the first look.
Sure. I think Hillman's been using a 10 sample moving average or something to denoise it a bit.
Yeah, that would I mean, but you can see it clearly. The line would just go right through the middle of this.
Sure. It doesn't look wildly wrong.
Yeah, the only thing is these numbers are off by a factor of 10 if you compare to the geophysical model that they have in Japan.
Bill, these are just almost exactly the numbers I'm getting out of the same device.
Yeah, so I think these are tens of nanoteslas. I think because if you look at the numbers in that IGY system, you'll get my numbers come out within less than 1% of the numbers on the system. As long as you take and multiply all these numbers by 10, then you get nanoteslas.
You're using the JSON output on the code from last week?
No, well, I don't remember. No, not on this. This isn't the JSON output. The only difference is a matter of decimal point between the JSON output.
Sure. Yeah, and which I corrected in the GitHub thing.
These are only counts of like 5. The width of your line is a count of 5.
Say that again.
The width of your line is only a count of 5, unless I'm reading something wrong. 1372 to 1378, maybe 4749 to 4754, 2170, 2180, now 2179 to 2174. They're only like a count of 5. So it's not very coarse. I mean, it's.
Yeah, but it'd be interesting to see how they change this coming week.
That's what I'm anxious to see what happens the next few days when a coronal mass ejection hits. Anyway,
although looking at the map, you're slightly below the impact, the zone of predicted impact. Alabama's a little bit south.
Oh,
it seems
right.
to
Okay.
come
Well,
down into Missouri and Pennsylvania, but they aren't predicting much. You should get something, but not a huge variation in Alabama.
We can try to have some data from other sources to compare with.
Yeah.
Yep.
Yeah.
Well, it'd be good to be on the fringe and to see what it does when you get out of the zone that hits.
Yeah, and I've got the grape going, so I'll be able to tie that in and see if we see similar kinds of things in the ionospheric numbers and on the magnetic numbers. So.
Well, guys, I need to go.
Yeah, we're a little over, so.
Yeah, I'm running down as well, so.
73s, everybody.
73.
73, everybody.
Good touch.
We'll see you on Memorial Day if you're up for it.
Yep. I plan to be here.
Okay, so do
Sounds
I.
good.
Nathaniel will be on field day.
What's that?
I said you'll be on field day.
That's right. All right, everyone. Have a good night.
There was something I was going to tell you, Nathaniel, and I can't remember what it is. So it
Okay.
couldn't have been that important, I guess, if I can't remember.
Well, if you remember, let me know.
Maybe it was just that John was going to be here tonight to answer any clock questions. So.
Oh, that's good.
So,
Sounds great.
yeah.
It sounds like you're making some progress with getting the parts then.
Yeah, I've got all the parts but 2. And one of
Which-
them I suspect I can build without. And
Yeah.
I'm thinking the way I'm going to do it is
That's USB.
That's the USB 3, right?
Right.
So what I might do is I might just build one board without it, because he's going to hit all these boards are going to be hand placed and then machine refloat.
Okay.
The first 25.
Right.
So we'll have him build me one. So if
Mhm.
there's some like, oh shit, like a short between power and ground or some catastrophic thing that we messed up on, I don't
Yeah.
waste all the parts and put them all on boards that are no good.
Right.
And so I can get one up, get the power supplies working, get the FPGA loaded, flash some LEDs, make sure I can talk to the parts, all the I2C parts. And then we can say, okay, good enough. Let's build the other 24. And by that time, the USB 3 parts will be in, and we can put all the parts on the board, and we can go back to the first one and stick that part on.
That sounds great.
Yeah.
So
And
you're
then-
missing the USB part, and then are you still missing the FPGA?
Yeah, I still am, but I have good pull in getting FPGA parts, and
Okay.
my rep says that for things like prototypes, Intel understands that if you don't feed the prototype market, that you don't get production, because you have to have prototypes first.
Right.
And then it's much easier to shake loose 25 pieces than it is 500 pieces.
Okay.
So while if we were doing a production run, we might be SOL. Doing
Okay.
this run of 25, we might actually be able to get the parts in a reasonable time.
Okay.
So that I won't know. It's like all these little tiny steps have to be followed, and they have to be followed in order. And it was first of all, you've got to negotiate with the rep and get the price. Then the rep has to go to the distributor and get the distributor to agree to his fantastically great price that he's giving us.
Okay.
And then the rep has to say, okay, here's the price and here's the minimum order quantity. And then if you order less than that, which of course we do, because the MOQ is 40.
Okay.
And they're expensive. So I don't want to order 40, I want to order 25. So now I have to go back to the distributor and say, I only want 25. And they say, well, we'll go to the factory and get a waiver for you so we can sell you 25. Then when we get that waiver, then we can actually enter the order into the system.
Wow.
Then once the order is entered in the system, then my rep can go in and say, hey, that order 1, 2, 3, 4, 5, we got to have that today. And go rattle some cages and see if he can shake some parts loose from. And what'll happen is there'll be somebody who is building production run who can take 25 less pieces until the next run of parts, and they'll juggle them around like that. And that's, I know this has happened in the past where we will get a small quantity like that by borrowing Peter to pay Paul later, you know, and they'll work it out. So I'm hoping that that'll happen, because we do have some clout with them. I mean, I have no clout with FTDI or Microchip, but with Intel, we got a long history with Altera. So hoping that it'll pay off here. I mean, after all, that's the reason I'm using this instead of Xilinx parts. Well, other than the Xilinx parts are too expensive. But I mean, you get good service, you go back, right? So hopefully that will be it, because like I said, without the FPGA, I can't really do anything. I
yeah,
but
that's a big deal.
Rather than just sit here, going like this, I've been building the FPGA image to verify that the pinout is correct.
Okay.
And that's gonna have to be done anyway, but I'm basically doing it as a test model. Okay, so I'm building the self-test code that we're going to use to verify the board when we get the board back from the manufacturer. Blink the lights, talk to the parts on the board, verify that every I2C part can talk to me and I can read a register from it. Can I read the temperature? Can I talk to the USB part? That kind of stuff. And then flash some LEDs when it's done. And I've got it, and that's one of the things that's going to be done while we're building, is we're going to have the CAD guy design us up some loop back boards.
Okay.
And it sounds simple, and I thought, well, this is a no-brainer. It'll take them 10 minutes to just connect up half the inputs to half the outputs, half and half. We'll feed the signals in, because all the IOs are bidirectional on the RF module. I don't have to program them the same as reading an RF module. I can program single-ended outputs that connect over to another pin that then becomes an input. And I just have to send a pattern on this guy and verify I get the same pattern here, and there's no shorts with adjacent pins or opens or anything like that. However, there's like 8 power supply pins, and we have to make sure all of the pins are soldered down. So that means I got to have 8 different LEDs to light up to show that each power supply pin is actually, because this is basically just determining if everything's soldered.
Okay.
I'm not testing any parts. I'm assuming that the parts will all work, that the design is correct. What I'm not assuming is that the parts are soldered down right. So if I've got an open pin or a short somewhere, I got to detect that, because even pins like, we're going to use RFM0 for our board, right? Well, the pins on RFM1 better be good, because the guy who buys the board is going to plug in another module, RFM1, when we come up with the transmit module, and all those pins better have been tested.
Yeah.
So I'm going to get a module that's going to plug on both RFMs at the same time and cross connect them. And you got to make sure to avoid adjacent pins. I could just bridge adjacent pins, right? But those are the most likely ones to be shorted. So I really want to take that pin over to that pin, go down the ways a bit so that you can get away from local shorts.
Okay.
So you'll be able to detect them.
Okay.
And then on the clock module, I got to do the same thing. It's a little easier because the board's much smaller and there's a lot fewer pins. But I'll come up with a code that you plug the two loopback modules on and an RF, a leaf board too, a loopback leaf board. Plug those three boards on, and then you can just basically run a go, no go test. And it says, yep, everything passed. Nope, everything didn't pass. I got an open somewhere. I got a short somewhere. And we did this on the, Dan and I used code like this for the Hermes board and for all the HPSDR boards. And the Hermes board, we actually did a two-prong test. Remember that, Dan? Where we had the loopback test, and then we had the Ethernet test. Because the easiest way to test Ethernet is just to connect to it. I mean, I don't really want to run a loopback test and try to figure out whether the parts solder down. We'll just run code that talks to the Ethernet as an Ethernet device. And if I can connect and transfer data, then it's good. On the I2C parts, you just have to read one register. If you're it's only 2 pins, right? You read one register, then you know that path is good. So you just go down, you read here, you read here, you read there, you're right there. You send a packet out, and maybe we'll loop back USB 2 and USB 3. I don't know exactly how we'll do that. Maybe we'll connect them to a computer, and just send a rudimentary message out, and come up with some simple thing. Even if you have to look at the computer, it appears as like a serial port, and you just see text come out on the computer, then you know that the USB port's working.
Yeah.
But something simple, because at some point we're going to have somebody manufacture these, and they're not going to want to sit there with an oscilloscope and check out each one. They're going to want to plug loopback plugs on and run the test in 30 seconds, pass or fail. And that way, if we send it out, and I learned this the hard way, have the test done as close to the manufacturer as you can. Because then they don't send you bad boards. Then you run the test and find out that 80% of them passed and 20% didn't. Now you got to send 20% of them back, have them fix them, and they all like to charge you for 100% of them. So if I make them do the test, I pay them to do it. And then what happens is when they don't pass, I don't ever see them.
They fix it.
They either fix it or scrap it or do whatever they want. And if their yield is crappy, then I pay a higher price and they just throw the boards away. Now, in our case, the boards are really expensive, so they're not going to want to do that. They're going to want to make them all pass, or a high percentage of them pass.
Right.
But that'll be on them. They're the CM after all, not me. So,
and
in fact, we're actually talking about, depending on what kind of grant we get, maybe we will use the grant money to build them here in the US.
Okay.
Because I think that would be money well spent. Have them built in Tempe where I can drive over to the place.
That would be nice.
And help them with any problems. I can set up the test bed right there at their plant. Trouble is, it's more expensive.
Yeah.
But
a lot more.
Yeah, a lot more. But we can optimize that. Like I think here's the example: the magnetometer board. I offered the guy the opportunity to build volume magnetometers and see what he could do for us. Well, the BOM cost of the magnetometer is about $9 to $10, somewhere in that range, not including the daughter card. That's just the baseboard.
Right.
The assembly cost, he was quoting me in 500s. I believe it was around $17 assembly cost.
Okay.
Which puts the cost about $27, our cost.
Okay.
So then you got to figure, you got to have some markup. So what can you mark it up? Well, the ideally you mark it up double, but that's going to be $34. That's too high as far as I can see. Actually, it's $54. It's what did I say? 17 plus $10 for parts. That's $27 for a unit. So it's $54 if you're going to sell it for double. Now, Tapper can get away with not marking it up double because we have lower overhead.
Okay.
So we might be able to make that fly. But if I could send the entire thing overseas and get it made for $17, including the parts, now you can sell it for $35 instead of $50. And remember, they got to buy two.
Right.
So $50 is $100.
Yeah.
So now you're starting to push up into the non-discretionary spending area, you know, where you have to start to think about whether should I buy this or not, as opposed
Right.
to, oh, $50, that's not no problem. And you
Right.
think about it
There
too
still
much.
is value added having it USA made.
Yeah, there is. It would be easier. And I mean, I don't know that the quality would be that much better, but you know, the problem is too, if we send them to our CM, we have to pay shipping. Well, shipping, and sometimes they hit us for duty also.
Yeah.
Because it's manufactured in the EU. And we've seen shipments of a box of boards, $500 to ship it.
Mhm.
Well, you know, so if you do 500 boards, that's one shipment as a dollar adder to every board. Just shipping them here is a dollar adder.
Mhm.
And then if there's any problem with getting parts or any, well, of course, that's really their problem, but it's just all around better to have it closer to the vest. I mean, it's just it's much easier if there's any problems at all. Now, magnetometer is not much of a brainer. I mean, I would send that to Europe without any trouble. But do I want to send a data engine with all these BGAs on them? I mean, they are hard to make, and if they can't make them right, and I guess this is the problem is if they have a poor yield and they get 5 rejects out of every 100, they'll just raise the price 5% and then we'll pay. But what happens if they get 5%, if they get 5 out of every 100 that pass? Well, they can't raise the price 20x. So basically they can't do it. It comes down to they can't do it, but they're not going to find out that they can't do it until they spent $20,000 worth of parts.
Right.
So, I mean, I look at the parts we got in the next room. It's mind-boggling how much money we have tied up in just the prototypes. Can you imagine a build of 500? And if they had a problem where they had some, like say they couldn't solder the FPGAs down right, it's a 672 pin BGA. That could be a disaster. I mean, and again, it'll fall on them, but that won't help me any.
Yeah.
I still won't get any boards, and you know, I don't know really what would happen.
Yeah.
If I had them bid it and they couldn't do it, what would they do? If they tried to build it and they got no yield, what would happen? I don't know.
Yeah.
But I think part of it is you really ought to match the build difficulty with the capabilities that you see the builder has.
Yeah.
So, and I know that the guy here has built boards like this before because he's built them for us.
Yeah.
Hell, he'll have built the prototypes. So, I mean, he knows what he's getting into. And if he has trouble, he will tell me right away.
Yeah.
If he can't do it, he'll be the first to tell me because it's his butt on the line if he can't do it.
Right.
He doesn't want to lose all that, not only just the business, but you know, it's the risk too, because he has to make good on it. If I give him $50,000, if I give him $200,000 worth of parts, you better give me back some boards.
Yeah. Yeah.
So anyway, we actually have a meeting with the ARDC coming up later this week.
Okay.
It's kind of a reporting meeting on what we've done with the money that they've given us so far.
Okay.
So I want to set up regular meetings with these guys because I expect that the next thing I'm going to ask for is going to be a whole lot of money. I'm thinking it's going to be on the order of $500,000 to $700,000.
Wow.
To build a run of 500. Do the math. It's expensive.
So, Scotty, I have a question. If you ask for a grant from them, what are you going to do with the money when you sell the parts?
Well, that's a good question. What the question is really, what do we pay for the boards versus what we sell them for? In other words, can we use the money to subsidize the sale of the boards? Just sell them cheaper?
Probably so. I mean,
That's one way.
They already
The other
want their money back, I don't think.
Well, they don't want the money back. I suggested that already, and they said no.
Yeah,
We're just
if we give it back to get rid of money.
If we give it to you, we don't want to see it coming back.
That's right.
That's kind of, so the other alternative is that we'll get the money back when we sell the boards, and then we use that for the next build.
Yeah.
And I mean, I think that's viable, but I think their thought is more like, well, spend all the money, don't get it back. We don't care. We'll give you more when the time comes for it. But that's great, except that, that's kind of like relying on something in the future that you don't know is going to happen.
Well, I really like the idea of, putting it toward making more boards, if you need to. And I don't know, I'm sure we could come up with other good ways to spend the money too, whether, putting it into developing antennas, or maybe we need something more for data infrastructure, or, I don't know, scholarships, or I'm sure we can find something good to do
Or
with it.
sponsoring a transmitter module, or
Yeah,
something that maybe NSF doesn't want to do, or doesn't,
yeah,
we think is good, but maybe they don't agree, or
Right.
they've got their other priorities and we've got ours.
yeah.
So
I think that's, I think that's a lot of it too, is just, what priorities people have. And
well, like, who's going to build Jonathan's RF module? I mean, who's going to fund that?
Yeah.
To build the prototypes and build the production run of it.
How
We gotta
much is
come up-
how much is that going to be?
I know he's been after me to give him a number, and I just don't have any number because I don't know what the parts count's going to be. But I mean,
Yeah.
you could guess based upon the data engine.
Mhm.
Take a third of the numbers, and you're gonna need $20,000 to build prototypes and to lay it out and build prototypes. And then you're gonna need $100,000 to build 500 of them,
Mhm.
or 1,000 of them, whatever, however many
Yeah.
you want to build.
Yeah.
But anyway, it's more change than I have, so
Yeah.
I got to look to somebody that has the pockets that and can be a go-between. And it kind of, ARDC and Tapper kind of fit the bill pretty well,
Yeah.
because
Yeah.
they're both nonprofit, they're both ham radio related, and the ARDC guys are just looking for a place to spend money that benefits ham radio. Well,
Yeah.
I don't see how you're going to find a better match than this.
Yeah. Yeah.
So
I agree.
but it's still a little frustrating because you're trying to get this thing out and running into all these roadblocks. And of course, if I had been earlier with the thing, they wouldn't be here because these shortages have come up just recently.
Right. But I mean, you couldn't predict that.
I couldn't predict that. And I mean, the timeline is what the timeline is. It just happens to have not worked out as well as I had hoped.
Yeah. Yeah.
But I think we've made a lot of progress in the evolution of the board set in the extra time that we took.
It sounds that way.
So I think if we had come out with this board a year ago, there'd be things that we would have overlooked that we've addressed.
Right.
Now.
Right.
And then you can argue whether it's worth it or not, but that's kind of a pointless argument since
Right.
where we're at now, and doesn't really
Right.
matter
Yeah.
what we could have done.
Right.
So anyway, on the parts, it's looking pretty good because I have good confidence I can get the FPGA. The USB 3 part, I'm not, it's not really in the mainstream of what we need.
Right.
I put it on there because it was $7 and it was an additional 5 gigabit port,
Right.
which was like, boy, that's about the cheapest 5 gigabit port you're going to get anywhere. And, we haven't really come up with a use for it. But
Yeah.
I'm thinking could be a back data channel to the Raspberry Pi. That would be not switched, not networked. It would be a direct channel to and from the Pi. And I mean, you could even stream raw IQ data over that and let the Pi do whatever it wants to with it. No routing, no minimal protocol. And then you still have the Ethernet for any other protocol that you want to do. So I start looking at this and I think, man, that FPGA is just not going to be big enough because of all those things that I want to do inside that part. And there's just not enough space to do all of it. So you're going to have to pick a subset of things. And so there's going to have to be multiple FPGA loads, I think, to do different things. So if you want a USB 3 version, you're not going to get, all the, and who knows, maybe you get more virtual receivers that way. And then let the Raspberry Pi handle all of the routing protocol, everything that Bill and his party have been working on all this time. and then just
Mhm.
say, oh, well, here's this big pipe down here that nobody knows about. We're just going to shove data into it. And
Mhm.
the Raspberry Pi all of a sudden has unlimited IQ data to do
Mhm.
whatever it wants to.
Mm-hmm.
But
Yeah.
again, that's not really the way we planned it. So I don't, it's there because I put it there just in case, but it's not really necessary for our first phase.
Yeah.
So if I don't get the parts, fine, I'll deal with the aggravation of putting them on later, especially since they aren't like 2022.
Mm-hmm.
I know
Right.
I forget what part it was that Nona kept, she come in every week and she give me an updated date for when the parts were going to be in. And I forget what part it was. I think it was the KSZ, the Ethernet part, before I designed it out. And then we canceled the order because they were giving me like June 22 for a delivery date. It's like a year from now, more
Yeah,
than a
that's
year from now.
crazy. Yeah.
Even the clock oscillators, for a 500 piece order, the lead
Mhm.
time is 140 days.
Wow.
So for
Wow.
production, if we're going to order 500 of them, we got to give them half a year.
Right.
So this is
Wow.
what my FPGA guys tell me. He says, well, if you're going to do production in Q2, that's
Mhm.
like April, May, June next year,
Yeah.
you better order now
Wow.
because that's the delivery time you're going to get. I know my other customer ordered FPGAs. They got a February Q2 delivery time.
Wow.
And they're beside themselves because they got other parts scheduled to come in and they have no FPGAs now.
Mm-hmm.
And it's the same as us. You have to have
If
it.
you don't have the FPGA, you don't have
But
it.
then you got iron sitting there that you paid for that sits there and you can't sell it.
Right.
Not good.
No. I hope things normalize sooner rather than later.
This can't be long term. It can't be, it just can't be like this because this is horrible.
Well, what I'm hoping happens, I remember with the vaccines, at least in Pennsylvania, it was like they were in this phase 1A category forever, where almost like very few people were able to get it. And they're like, they had no anticipated date for when they would open it up to anyone else.
Right.
And like it just went on like this for a couple months.
Right?
Right.
Yeah.
And then all of a sudden they're like, oh, next Tuesday, everyone's eligible.
Yeah,
It's just
and
like
that's
out of
what they
thin
did
air.
in Arizona too. They
Yeah,
had
it's like
next Tuesday now. They extended it down to 65,
right.
and then 2 weeks later, everyone.
Yeah.
It's like, what did you get? Like a windfall of 2 million vaccines or something?
Right.
I mean, don't know.
So I'm hoping it's something like that with these chips and the
Yeah.
lead times and stuff.
Well, and I think a lot of it is that people think that they like to think the worst because that makes headlines.
Mm-hmm.
And they think, oh, look, you're getting it. Well, the reason I'm getting June 2022, and we found this out from one of the distributors during the DRAM shortage, it's not because it's June 2022. It's because that's the longest time that they can give you. They don't know. So they put in the longest time, FFFF. They fill it up with the biggest number that will fit in the field that the software will take.
Mm-hmm.
And that used to be 99 weeks.
Okay.
So it was obviously 100 was the minimum, was the maximum. So I would look down because why is it that everyone has 99-week delivery?
Right.
That makes no sense.
That's
Well, it's because that's what the software takes in is there. I don't know, and I'm not going to know. And then all of a sudden, 10 weeks later, you start seeing deliveries coming in, and pretty soon, no problem. How many do you want?
Right.
Because the thing is that, I mean, if Microchip has no parts to sell me, they don't make any money either.
That's right.
So, and I asked the rep this. I said, well, you know what? It's not like that the Wonder Bread factory suddenly can't make bread anymore.
Mm-hmm.
I mean, they're making just as much bread as they made last month. So why is there none available at all? Somebody is taking these orders, taking these parts, ordering them and buying them and getting them. Somebody's getting parts. Just because I can't doesn't mean, somebody's getting them because the lines are still running. They're still making thousands of chips, but I just don't see any. And he doesn't have an answer. His argument is, well, like for FPGAs, they're actually, interestingly enough, if you buy the ARIA 10 FPGAs, there's apparently there's no shortage of them because they're made on an Intel fab line.
Okay.
But the smaller parts like ours are made on a TSMC fab line, which is it's a outsourced.
Yeah, it's Taiwan Semiconductor Manufacturing.
Right, and Intel doesn't own that. So what happens is TSMC says, well, Analog Devices is going to pay me twice as much to build their parts, so you have to wait because we're going to build their parts, and or whatever it is like they get bid out, or the guy with the biggest clout, the biggest customer maybe gets more share. I don't know how it works. But anyway, so he says, well, maybe that's why you don't get any parts, because they really aren't making that many. Because you're waiting for the next wafer fab, and then they'll make 100,000 or 1 million, and then they'll be available for a while, and then they'll dry up again. Because it goes in bursts. Whereas at Intel, if they had their own fab line, they would just schedule enough fabs to meet the demand, and then there wouldn't be any shortages. And then you get to pay $2,000 a chip, because that's what ARIA 10s cost.
Yeah, so I guess ARIA 10s aren't a viable option then.
Not for us. In fact, the Cyclone 5, I've been while we're having this fight, I try to get prices for Cyclone 5s, but I really don't want to ask the rep for really good aggressive prices at a time when he can't get any parts.
Yeah,
because he's told me this is not normal times. He says, I can't give you really good prices because I can sell every one that I make. So I'm not going to give you a discount price when I can sell them at higher prices. But that Cyclone 5 part that I want to use on the next generation is like a $200 part. If you just go to DigiKey, and assuming you can even find them, which I don't think you can buy them at all now, but when you could get them a few months ago, they were like $200 or $210. But I don't pay regular price. I mean, he gives me a special price, and that's part of what our deal with him is. But I can't get a special price now because this is not the time that they're handing out special prices. So I'm going to wait. But I think
that makes sense.
The CVA9 is the part I'd like to target, and I think we could take 90% of the board and just rip out the FPGA and put a new one in, and keep all the rest the same. And so we would verify all that stuff would be already verified because it's already laid out and working. Or if it isn't, we'll fix it. And then we'll do the same thing as to take the heart out and put a new heart in. And then we'll get 6 times the LEs, and we'll get a faster speed. So that will be pretty exciting to have a CVA9 like Dan, like the IQ2 size FPGA on one of these boards.
Yep, that would be good.
But then the question is, I mean, you got to step. Just because I can build it doesn't mean anybody's going to want one. Because the price is going to be higher. So then the question they're going to ask is, well, what does it do for me that the other board doesn't? So maybe I can give you 32 simultaneous receivers instead of 8. Would that be better? I don't know. Well, then you run into the Ethernet limitation of how many streams you can have in 1 gigahertz, 1 gigabit. And so then what you end up having to do is you either have to make the data narrower, like truncated to 14 bits or 12 bits, or you have to use narrower filters. So in other words, instead of 384K slices, I get 192K slices, or 96K, or 48K, or 24K. And that's the beauty of the way we've got it set up, is if you want to get a pan adapter display, you can have a wide but not deep display. Because I only have 1,000 pixels across the screen. There's really no point in having more than 1,000 FFT bins. Because you won't see them anyway. So and that's what Flex does. That they have a special, and Elecraft does the same thing. They have a special stream that is just for displaying. You don't demodulate it, and it takes up a lot less bandwidth. It's actually a raw stream. I think they just send like 1,024 samples, and then you do an FFT on that, and you display it. and then you send 30 of those a second. So you get a 30 frame per second update for 1,000 bins. And you never demodulate that. So then what you do is when you want to, if we're doing narrow band stuff, then you can have many more virtual receivers if they're narrower.
Right.
So suppose I told you could have 12 kilohertz receivers or 6 kilohertz receivers. I mean, you could do a single signal in 6 kilohertz, right? Easy.
Yeah.
But then you could have 1024 of them. Or some huge number. That means you could spread them all over the band, little teeny slices all over the band. And then maybe you can have a few larger ones for areas that you want to look at a wider area. But so anyway, just tons of possibilities.
Yeah.
And
I think I better go, Scotty.
Yeah. It's late for you guys.
It is. It's almost 11. So.
Yeah. Okay. Well,
thank you so much.
Have a good Memorial Day, and we'll see you on Memorial Day.
You too. I will talk to you soon.
Okay.
Thanks, Scotty.
7-3.
7-3.
We'll see you in the morning, Dan.
Oh, okay. Are you going to send out invites to
Oh,
everybody?
yeah. Did you want to do a pre-meeting or not?
Yes. I
Okay.
already contacted Steve.
Okay. We have a commercial version now. So.
Oh, good. Okay.
And I'll give you the login to that, and you can run it from after this one.
Okay, great.
At some point. So
Okay.
I'll give it to you. I'll give it to you tomorrow. I'll send it out for 9 and 10. Is that good?
9 and 10, just like before, just like last week.
Okay.
Okay, talk to you later.
See you tomorrow.
All right, good night.